Good day to all of you. Today is April 12, 2020. Once again, our subject is internal combustion engine, and our topic is valve failures. This is the continuation of our previous topic, and we have a subtopic which is valve breakage. Alright, let's begin. We have engine valve breakage. Breakage, which is the other main type of valve failure, this can happen to either intake or exhaust valves. Valves break in one of two places, where the head is joined to the stem, or where the valve grooves are machined into the end of the stem. Either way, breakage is bad news because the pieces fall into the combustion chamber and wreak havoc on the piston and head. When we say wreak havoc, it's said to be causing great damage. So you can see there, wreak havoc. Okay? So what do we see here? We can see that a valve was stuck in the piston because it broke. So when the head of this valve fatigued and broke off, it stuck on the top of this forged piston. Had this been a cast iron piston, it would have shattered and probably the entire engine. So this is the result of a fatigued valve. So it broke off there. So it was stuck in the piston. Now let's go to the causes of the breakage. Causes of head breakage, this is valve head breakage, include fatigue, failure from valve flexing, this is from off-square seating that causes the stem to flex every time it seats. Okay, so it's off square. When we say off square, it's not centered or concentric. So every time the valve is seated, it flex or moves there because it is off square or not centered. Next, we have pounding, fatigue failure from pounding. So this is from the result of excessive valve lash. When we say excessive valve lash, this valve lash means this is the valve adjustment. So when the valve adjustment is excessive or it has a big gap, so the tendency is the valve will be pounding from the seat. So fatigue failure from pounding. Okay, next is stretching. Stretching is from excessive heat and or RPM. Okay, so valve is stretched from excessive heat. So we know that metals become heated, they stretch. Okay, so same with RPM, because too much speed will make them stretch, because too much speed also causes heat. Okay, fatigue failure from thermal shock. Sudden temperature changes as when abruptly shutting off a highly loaded engine. When we say thermal shock, so there is a sudden temperature change. So from the hot or warm state or hot state, when you suddenly shut off the high loaded engine, it becomes suddenly cool. So there is a thermal shock, like a glass. When you put a boiling water from the glass and then you remove that, and then replace it with a cold one, the glass breaks off. So this is an example of a thermal shock. With two-piece valves, the junction between the stem and head is where the valve often cracks and separates, not because the valve is defective, though a poor weld could be a factor, but because this area is highly stressed due to the joining of two dissimilar alloys. Okay, so we can see a valve here. This is an example that there is an alloy which is dissimilar. So from this portion and that portion is different. So if we may, I will focus it, and then you see the difference of the alloys. That's where the junction between the stem and head, and where the valve cracks often and separates. Alright, so you can see this is dissimilar. They are not the same, so we can see the color. Alright, let's go to valve stem tip breakage. So now we know the joint of the head and the stem is also an area for valve breakage. Now there is another one, which is the valve stem tip. Okay, so in the valve stem tip there is also a breakage there. So breakage at the stem tip can result from excessive side loading if the installed stem height is not right, and causes rocker arm misalignment. Okay, so from excessive loading if the installed stem height is not right. Okay, so valve has a stem height. If it's not right, then it will cause the valve stem tip to break and causes the rocker arm misalignment. Okay, next, it can also be caused by excessive valve lash that prevents the valve train from cushioning the valve as it closes. Excessive valve lash means excessive valve clearance. So this prevents the valve train from cushioning the valve as it closes, meaning it will not, when we say cushion, it will not absorb the coming back of the valve to its position because of the spring force. So if you have excessive valve lash, it will not absorb this valve return like in its position because of the excessive distance or clearance of the valve to the rocker arm. Next, another condition that may cause the tip of the stem to snap off is wear or scratches in the groove or coil bind. So the stem would snap off because of wear or scratches. When we say wear, it has already like corroded or some parts wear off or was not there anymore. And scratches meaning they are just like wounds or scores in the groove. So that's a reason why the stem will snap off, because the hold of the locks anymore is not firm because it's already worn out and is scratched. Also, coil bind is another reason, because the coil is binding. What's coil? That is the spring. So it binds there because of too much lift. Okay, let us proceed to the other valve problems. So in addition to burning and breakage, there are a number of other valve problems to watch, some of which may indicate underlying problems that also needed to be corrected. So look at the picture here. We have valves which are bent. Bent valves can result from over-revving the engine or a broken timing belt, timing chain, valve spring, or camshaft. The damage occurs when the piston, or rather when the valves or valve hit the pistons. Okay, so this is a broken valve spring. So bent valves results from over-revving, meaning too much engine revolution, and broken timing belt or chain. So the belt was cut, and also the timing chain because it's broken, and also the valve spring and the camshaft. So valve spring, we can see those valve springs are broken. Bent valves are usually the result of a close encounter of the worst kind between valve and piston. Okay, so we have already explained this, that the cause of bent valves are a broken timing chain or belt, weak or broken valve spring, over-revving the engine, and another one we have valve sticking. So valve sticking is a cause, or rather a reason for bent valve, because the valve sticking happens when it has insufficient valve guide clearance or insufficient lubrication, and we have overheating and others. And last one is insufficient valve to piston clearance. So if the clearance of the piston is there in the cylinder, and the valves are on the cylinder head, if they have insufficient clearance, then they would strike each other. Worm stems. Worm stem is a normal condition for high mileage valves, but scuffing or scoring may be a clue to insufficient guide clearance, overheating, lack of lubrication, or dirty oil. Using the wrong type of valve guide seals can sometimes be a factor. So here, worm stems meaning the stems are now becoming less in diameter because they are already worn out. So these are from worm stems, come from scuffing or scoring. Okay, and it's due to what? Insufficient guide clearance. Okay, and overheating, and lack of lubrication or dirty oil. Okay, lack of lubrication meaning the oil did not reach there, enough oil did not reach the valve stem where it has contact with the valve guide, so it may be scored. Okay, so that's why the stems were worn. And also dirty oil, because oil must not be dirty when it comes to lubricating the moving parts. So if your oil is dirty, then worm stem would happen or would occur. Next one. Okay, here in our picture we have another problem, which is heavy carbon deposits on the valves, which are caused by worn valve guides and seals. Alright, so the oil comes inside, it's drawn inside, and because of the heat it's also burned. So that's why we can see lots of sooted black substance which are carbon deposits can be seen on the valve stems. Also, worn seals, valve seals. Okay, not just worn valve guides, but also worn seals. So worn seals admit or permits oil to go inside the combustion chamber rather passing through the valve, and it's also burned like this. So let's go to the conclusion. The bottom line to valve failure analysis is this: replacing a bad valve with a new one won't fix anything if there is an underlying problem that has not been corrected. So even if you replace the bad valve with a new one, if you won't fix other problems, then, or any underlying problems, then it would not be good for your engine. So following accepted valve and seat refinishing techniques, leaving adequate valve margin, proper seat positioning and width, checking and correcting installed stem height and installed spring height, maintaining adequate stem to guide clearance and valve lash, and ruling out other engine problems such as overheating, detonation, air and fuel, or timing problems, etc., will go a long way towards preventing repeat valve failures. So all of these must be checked, alright, so that your valve is a sure success when you put it in the engine. Alright, so this ends our topic. So let's have a short quiz for this. Okay, please answer this. 1 and 2. Answer. These are places in the valve where it breaks. And 3 to 7, we have causes of valve breakage. Give causes of valve breakage. And 8 to 10, give other valve problems. So this has been Teacher Lim again. Thank you very much. Have a nice day to all of you, and stay safe always.